Do you enjoy gambling? Or are you a fan of probabilities? Let's open up a console casino and build our own slot machine. This will be our random money grabber. Perfectly legal. A neat fruit arrangement with some dopamine triggering animation to keep players hooked. And yes, it's also an excellent excuse to explore random choices and their keyword argument weights. Woohoo. Look, I won. Step 1. Let's start coding. The heavy lifting will be done by Python's random module. For our animations we'll recruit OS to clear the screen. And we need some sleep from the time module. Step 2. Define the basics. Every slot machine has reels with symbols. Choose your favorite emojis. My slot machine is basically a healthy fruit salad crowned with a diamond. Fancy. Players need properties too. Cash, money, coins. And each spin costs them one money thingy. Voila. Our globals are set. We'll add more as needed. The machine's main job is to spin the reels. And return random symbols. The method random choices takes an iterable. That's our list of symbols. And k as a keyword argument. That's an integer, the number of reels. It defines how many choices to make. Each choice is independent, so duplicates, like 3 oranges, can happen, and pay out. There's a sibling method, random choice. It picks just one item at a time. You could use it with a for loop, and call it thrice, once for each reel. But I'm a shortcode enthusiast and go with choices. It's elegant and concise. Print and done. Thanks for watching. No, stopping here would be boring. Let's spice things up with values and weights. We want small wins and big wins. There is a diamond symbol for a reason. Let's go back to globals. For step 3, add symbol values. Different symbols should pay differently. For each symbol we define a value. Map them within a symbol values dictionary. This way cherries might be worth 1, lemons 2, oranges 3, etc. They all will result in different payouts. Let's put that in a function. The player's bet will be multiplied by the symbol's values. If you stop here, never open a casino. You'll be broke in a day. Step 4. Adjust probabilities with weights. Higher value symbols should appear less often. Otherwise, we'll go bankrupt. Use the weights argument in random choices. This is an optional keyword argument. If omitted, all items will be weighted equally. We'll tweak destiny here. To create weights we reverse the values. So the least valuable symbol is the most common. Giving small wins and big hope to the player. The diamond will rarely show up. Without weights, every symbol has a 1/36 chance of a triple. With weights, cherries might hit at 2.33%, while diamonds barely register at 0.01%. Welcome to Casino Economics 101. Step 5. Build the animations. With these evil likelihoods the player experience must be sufficiently addictive. So we need some functions to enhance the user experience. Some animation to build up excitement. And some practical functions. To animate we need to create frames. We'll print and clear the console fastly. That only takes one line of code. CLS is the bash order for Windows to clear the terminal and clear is for Mac and Linux. The display function will take the results from the spin slot machine function. Clears the console. And will print the symbols neatly formatted, separated with lines. Next is the spin animation. We'll trigger our predatory instincts. Anything that moves is interesting. We take the 3 symbols and make them appear one by one after spinning. This spinning will be a fast sequence of random symbols. This way the player gets excited when the first is a high value, or more excited when the first and second are the same. All reels spin. They one by one stop and show the result. Note, this time we use random choice, singular, because it's only one symbol at a time, and there are no weights. This creates the illusion of higher value symbols being common. Evil? Yes. Effective? Absolutely. For a smooth animation there is a tiny delay between symbols. Delay is now a keyword argument with a default value. You may experiment with different delays. That's the first animation. Let's create the other, the win animation. If there's a win, the reels flash and blink to release maximum dopamine. We alternatingly display even and odd reels, and again have a minor delay in between. We'll show this beauty if there is a win. You could add sound or more graphics to imprint the win in the player's brain. They'll keep playing to get this dopamine trigger again and again. So let's check the results. This is step 6. Results are a win if all symbols are the same. Simplest check. Convert the result list to a set. Duplicates vanish. If its length is 1, it's a win. Bonus. This works for any number of reals. Just tweak the global reel count. You can check for a win in different ways. This would be another option to compare, but limited to exactly 3 reels. While this version is again more flexible with the number of reel. Lastly, a function we need, but do not want as casino moguls, is a quit function. The player needs to be able to leave the casino. We want them to stay. So we ask them to press enter to play first. But we'll check if they quit. Ready to run the console casino? Step 7. Let's build the game loop. Start with a welcome message. And initialize the player's money. The gambling loop will last, while the player has money. And doesn't quit. We'll take their money and deduct the spin cost from their balance. Spin the reels. Mesmerize the player with our animation. And show the random results. Check for a win. Trigger the win animation if applicable. And pay out. With a big shark smile and congratulations. More often the player will lose. Oh, no luck this time. If the player runs out of money, bid them farewell. With a smug smile. Congratulations. You now own a console casino. With a money-making slot machine. Customize the symbols, weights, and values. And observe how quickly players go broke. If you've grasped probabilities and random choices, hit that like button. Subscribe for more Python-powered dopamine in the future.